Hey guys, it's Mr. Calderon with Queen My Pawn. I'll be going over what exponential functions are and how they can be applied to in real life. Exponential functions are defined by slow growth in the beginning and then rapid growth all of a sudden. You could think of, for example, bacteria. Bacteria do replication by dividing in two, and one bacteria becomes two bacteria becomes four, and so on. And if you divide two bacteria per hour, then you'll find that after a certain amount of hours, you have like this big colony. But you can also think about it in terms of money. So let's say that you have 1 penny. And after every day, you get that doubled, okay? So after 1 day, you have 2 pennies, and 2 days you have 4 pennies, 3 days you have 8 pennies, and so on. And a typical question is, would you rather prefer to have $1 million given to you now, or do you want to wait 30 days, but get your penny doubled? Well, if you really need the money, you should get the $1 million, but if you think you'll live for 30 more days, then you should definitely pick the pennies, and here's why, okay? I'm gonna share my screen right here, and here's how it works, right? In the first day, you have 1 penny. Then after 1 day, you have 2 pennies. After 2 days, you have 4 pennies, and so on. This is a function that's nonlinear. It's characterized by y equals 2 to the x power. Basically here, you double it every time that a day passes. So over here, we don't double it at all on day 0, but after day 1, you start with 2. And then 2 times 2. And yeah, I don't know why my thing is doing that. It's weird looking too. And then 2 times 2 times 2, which, it's 3 2s, so you'll have 8. And you do this until you get to 2 to the 30th power. And put this into Google, 2 to the 30th. I don't know why this is happening. Let me just do it over here. 2 to the 30th. Put that in Google by doing 2 carat 30. That carat sign is shift 6 on your keyboard. You're gonna get a crazy number. And that's why you should definitely pick the penny doubled. Okay, so what are actually exponential functions? Well, they're characterized by a base like 2 or even 3 or 5, any positive number to the x power, like that. Now I said any positive number, so that means that -2 to the x can't be, because when x equals 0, then y equals 1, and when x equals 1, then y equals -2, and then when x equals 2, then y equals 4, and it's not exponential because it goes down and then up, but exponential functions only go up. We'll see more of that as we go on. Another non-exponential function is 1 to the x power, because no matter how many times you multiply 1 by itself, it's just going to be 1. So an exponential function is going to be b to the x as long as b is greater than 0. B is greater than 0, and I'll put an and sign right here, and b is not equal to 1. Okay, so that's basically it. In fact, that car has some serious stomach issues. I don't know why I just pasted that either. Okay, That was a car right outside my window. I need some Pepto-Bismol, man. Oh my goodness. All right, so here's another thing about exponential functions. Let's start it off with 2 to the x, right? And let's examine this on decimals. So I'm gonna share my screen over here on my computer, and we're gonna take a look at some exponential function graphs. So Decimals is a great website for learning what certain graphs look like. And you go straight to the graphing calculator, or you can put decimals.com/calculator. Let's put 2 to the x now. So as you can see, it starts off real slow. Then it just goes up and up. Let's scroll out. And you can see that just shoots straight up into the sky like a rocket ship. That's what exponential functions are. And if you go to the left, you can see that it basically looks like it's 0, right? But actually, it's not 0. It's just very close to 0. I know that it says 0 there, but it's not. It's going to be like basically rounded to 0. But an exponential function can never be 0, because if you multiply the number by itself, how are you going to get 0? That's impossible. You're just going to get a really small number. And here's what I mean. So another website I like to use for drawing is Whiteboard, and maybe I'll just use my mouse. If you have 2 to the negative x, you're going backwards, right? Or you could have 2 to the x. Let's say that x was like -3, right? Well, 2 to the -3 is going to be what, guys? Try to figure it out for yourself before continuing. Maybe you know it, maybe you don't. Now, notice that this is very different from -2 to the 3. They're different numbers. And here's the rule about negative exponents. It's going to be the same exact thing, 2 to the 3. They're the same thing, except it's going to be a fraction, and it's going to belong on a denominator. 1 over 2 to the 3rd power, which is just 1 over 8. So as you can see, it's also 1 over 2 times 2 times 2. So no matter what, like this number is going to be really big, and this number is going to be small relatively. So you're going to get something like small over big. Excuse the bad handwriting. But this is never going to equal 0, because they're both not 0. So yeah. It's like, for example, you are in a crowd of a lot of people in New York. Your like influence, like that one person, you're not 0. You're like a small fraction of that crowd, but you're not 0, because if you were 0, you'd be insignificant, but you exist in that crowd. So that's why 2 to the x power will never equal 0, or base to the x power will never equal 0, as long as it's an exponential function. All right, let's look at some other graphs, by the way. So that's the original 2 to the x, but I talked about reflections in another video, I'm sure. If not, I'll make a video about it right now. So either you check out transformations of functions in the video I make, because it doesn't exist, or you go into my YouTube channel and check it out. Either way, just look for it, because it's there. Another thing about exponential functions is, let's say you have something like 2 to the x times 2 to the 5th power. So how do you work with this? Well, first of all, let's consider something like 2 to the 3rd times 2 to the 2nd power. And now I'm going to go back to my laptop to draw, because this is getting annoying. Hang on a minute. So I'm gonna share over here. Okay. So 2 to the second times 2 to the third. Well, here, you're gonna get some number, right? But without using the calculator, you can see what this is quickly. You got 2 to the 2 times 2 over here, and then you got 2 times 2 times 2. So in order to get the answer, you just count the twos. That's 2 to the 5th power, or 2 to the 2 plus 3 power. So as you can see, the bases are the same. You can add up the exponents. So when you have 5 to the x times 5 to the y, you could just say 5 to the x plus y power. Okay. Now be careful. This isn't something that you can combine because you're adding. You have to be multiplying them, because then you get this rule. You count the number of fives you're multiplying with each other. Another rule is this. Let's say you have let's say you have 2 to the 3 to the 4 power. That's going to be 2 to the third times 2 to the third times 2 to the third times 2 to the third. And when you write them all out, you get 2 times 2 times 2, and so on. And you're going to end up having 12 twos. So it's going to be 2 to the 12th power. But look what I just did. I just multiplied that number and that number. So that's called the power of a power rule. So something like 5 to the x. Let me just do it over here. 5 to the x to the y power. That's just 5 to the x times y power. And finally, a quick rule that I skipped because it's simple to understand is something like, what about 2 to the second divided by 2 to the third? Well, that's going to be 2 times 2 over 2 times 2 times 2. That cancels out, and then you get 1 over 2. Or, like we saw before, that's just 2 to the negative 1 power. Because the 2 is on the bottom of the fraction with 1 as the numerator. And this is how many times it's on the bottom. Since it's on the bottom, you add the negative. All right, I think I've said enough about exponential functions. I want to say more, but I don't think there's anything more to say. I'll talk about transformations in the next video coming up if I haven't made it. I'm just not sure. But it's going to be there. So look for it. Stay tuned and make sure to comment if you have any questions. Click the like button and make sure to subscribe. Thanks, and I'll see you on the next one.